My name is Vashti Sawtelle, and I'm Assistant Professor of Physics in the Physics Department and in the Lyman Briggs College. Yeah, so diversity for me is more than just demographics. It's more than just thinking about like the ethnicity or racial makeup of their individual classroom. It's about thinking about who's in your class and what kinds of experiences do they have and what are they drawing from. And so when you want to create a diverse classroom space, what you're looking for is a space that really draws on those different kinds of experiences that students have. So we did a number of studies at Florida International University, which has a very diverse student population coming from a lot of different backgrounds across the world, but also coming from a lot of different experiential backgrounds. And when we were looking at the communities that get created in that classroom environment, we were trying to say, if you create a more diverse grouping, if you make your classroom draw from these different experiences, do you see a differential impact on student outcomes in terms of both their persistence through the science major? In particular, we were focused on physics and the life sciences, and also in their learning of physics. So we use standardized national assessment tools for looking at their learning of physics content knowledge. Yeah, so one of the surprising results that we found in terms of the kind of makeup that the group has that has the most substantial impact on their outcomes is that things like having a diverse group of majors actually has a strong impact. So having not just physics majors in the classroom, but also having life science majors and biomedical engineers and math majors, all part of that community group, actually better predicts persistence through the major than having just physics majors, for instance. And it also better predicts the successful physics content learning, which is an interesting thing. So not just having more than just physics majors makes everyone learn physics better. Similarly, we looked at other kinds of characteristics of those community makeups, and again, Florida International University has a very diverse group with lots of people who are non-traditional science students. So they are coming back to school after having other careers, other kinds of jobs. And if we mix those into the community, we also see an increased improvement on things like persistence and retention, particularly for those students. And of course, we explored things like gender and ethnicity, and as we would expect from a lot of other kinds of people's work, that having more gender diverse, more ethnically diverse groups better predicts the outcomes of retention, persistence, and physics content learning. Right. So in my current work, I've taken that concept of diversity as being the idea of people bringing different kinds of experiences into the classroom, and it has, I've expanded that into sort of two threads. So one is thinking about in creating classroom spaces that really embrace that. As physicists, we often teach a large number of people that are not physics majors. And so thinking about how do you really bring into the classroom the kinds of experiences that your life science majors are having, and the kinds of things that they know, they're very good at knowing, and how do you actually use that to help them learn physics. And the second strand is thinking about, as those students are interacting with physics, often they don't see themselves as physics people, or maybe even see themselves as science people. And so exploring what kinds of things can we do in the classroom that help them see themselves as more part of what science learning and physics learning is really about, and see themselves as potential scientists later in life. So modeling and instruction is a curricula that was developed at Arizona State University and has taken hold across the country. It exists both in a high school classroom format and also in a university calculus-based physics classroom format. They look slightly different because those two environments are different. But the thing that holds them together is an emphasis on a few robust models that tie all of physics together from a content perspective, but then also pedagogical techniques that really embrace students' diverse sets of experiences. So for instance, modeling instruction, a lot of people, if they've heard of modeling before, will think whiteboards immediately. So we tend to use these small personal-sized whiteboards and have students do lots of work on those whiteboards. And part of the goal from that is to get students to put the things that they are experienced with and things that they know from other places into the classroom. So the modeling instruction broadly has a lot of different instantiations. The way that I implement modeling is connected with this trying to bring in life science majors kinds of experiences. So an example of doing that is we have a problem in my class, right, where we would think about how an amoeba moves across a slide. And the question is what kinds of things would an amoeba need to think about, an amoeba doesn't think. What kinds of things would an amoeba need to use in order to move across a slide? And when you build these diverse classrooms that really value people's experiences, what you see happening is that the life science major brings in stuff that they know about the structure of an amoeba and how it undulates through water or whatever background it's moving in. But you also have things like mechanical engineers or someone who's had a lot of experience working with their parents on vehicles or something like that are saying things like, well, if it had a flagella that was spinning, that could propel it through the water. And so what you end up doing is having this really interesting experience where students are sharing those kinds of perspectives and building together a model of how an amoeba might move through water on a slide. And one strand of my research is thinking about how people come to see themselves as science people and as physics people. And so what I really mean by that is you'll have a lot of students, especially if you think about teaching life science students, who say things like, well, I see myself being a doctor someday, but they don't necessarily see themselves as being a science person. And even more so, when you're teaching them physics, they say, well, I'm good at biology, but physics, I'm terrible at that, right? And so the work that I'm doing is trying to ask, how can we start to move students along those different perspectives? So saying, how can we bring more of their, I'm a science person, which is connected to being a medical doctor, how can we bring that more into the classroom, and how can we connect that with physics in particular so that students walk away saying, okay, maybe I'm not a physics person, but physics is relevant to me. And maybe they start to consider themselves as being a physics person. Maybe this is an opportunity for them. And so that's those ideas are what we label as science identity or physics identity, and having those sorts of identities with our affinities with science and physics. And one thing that we've found is that doing things that really leverage biology expertise in the classroom can do work to help students see that as relevant and useful to them in the physics classroom. And in doing so, they start to see physics as part of what they're up to. So one of the examples that come to mind for me in this is in biology classrooms, students often talk about osmosis, like movement across membranes. What happens in my physics class is we unpack how does diffusion actually work? What goes on in that process? And what I hear students saying is we have so much to do in biology that we never really get to stop and ask that question. Why does it happen? How does it happen? And in my physics class, by bringing those things in and connecting them to the why and the how, students start to say, oh, this physics thing is actually answering questions I'm interested in. And so it's really doing something to help connect their sense of interest and their sense of engagement with biology to their sense of asking why and how questions that physics is good at answering.